All right, yeah. So find your standard deviations. 2 standard deviations, 2 times 2.6. Subtract and add those from 24.0 to get your min and max. Or you can draw a picture. And like we said, 30 chocolate chips is my minimum usual value is 18.8. My maximum usual value is 29.2. So most chocolate chip cookies should be between 18.8 and 29.2. This is definitely over that. Angel.
Will we need to know how to use the formulas for the exam, or is it okay if we just draw the little...
It's fine if you, I don't need formulas. I hate formulas. In general, I think formulas are bad. Because you shouldn't have to memorize stuff. It's not the point of this class is to memorize stuff. Right. There are a couple of things in chapter 8 where I kind of make you find a couple things. So you have to show me your work, if that makes any sense. So, you'll have things like that, but showing your work is important. Here it is prettier. Comparing variation different samples. Rob, go ahead. Actually, Rob, go ahead.
Comparing variation in different samples. It's a good practice to compare 2 sample standard deviations only when the sample means are approximately the same. When comparing variation in samples with very different means, it is better to use the coefficient of variation.
Right. So I have a bunch of pieces of paper. Right, I've got like this piece of paper and this piece of paper and some other pieces of paper. And their variation is like 2 inches. Or their standard deviation is 2 inches. That's a fair amount. That's a reasonable amount, right? I would say that variation of 2 inches might be, or standard deviation of 2 inches might be a reasonable amount, or fairly large. But, or even say it's a variation, standard deviation of like 4 inches. That's even larger, wouldn't you guys say? If a piece of papers, all these papers had a standard deviation of 4 inches. But, if I have 5 or 6 buildings, and I measure the width of these buildings, and the standard deviation between these buildings is 4 inches, that's like nothing. Do you guys understand what I'm saying? If I'm comparing buildings, and then they vary from each other by about 4 inches, that's not very much. They're almost the same size. So it's really important to consider what percent of the whole your standard deviation is. The mean is kind of your best number for the whole. It's the average, right? So you compare the mean, the standard deviation as a percentage of the mean, and that's kind of what this coefficient of variation is. Oops. Okay, that didn't work well. Hold on. So coefficient of variation is when you take the standard deviation divided by the sample mean, and then turn it into a percentage, multiply by 100%. Because 100% is just multiplying it by 1. For population, you do the same thing. Take your standard deviation, divide by the mean, multiply by 100%. So you guys all find it for the Chips Ahoy cookies in the last example. So just use 2.6. That's fine. Use 2.6 for your standard deviation, and take 30 seconds and find it. All right, Jacob, what'd you get? And how'd you do it? Jacob? I'm sorry? Okay. Ivana, do you want to help him out? What'd you do? Seriously? Take the standard deviation, divide by the mean, multiply by 100%. Jacob, did you get it yet? Rhea, what'd you get? So what did you do?
6, which is this,
Standard deviation.
divided by x bar, which was 24, and you multiply it by
Yep. And then you got
10.8.
10.8%. Good. Perfect. Yeah. You could just use. Yeah. I like 3 sig figs. So 10.8 or 10.83 is fine. Either one's okay. I'll be fine with either. All right. Now we have Chebyshevs, which is fun just to say. Chebyshevs. Jacob, go ahead and read for us.
The
Proportion.
or fraction of any set of data lying within a standard deviation of the mean is always at least 1 minus 1 divided by k squared, where k is any positive number greater than 1.
Keep going.
For k equals true, at least 3/4 or 75% of all values lie within 2 standard deviations of the mean.
Right? So in other words, when we're talking about 2 standard deviations, it's k is 2, then you would do 1 minus 1 over 2 squared. Whatever the number of standard deviations you want to do, squared. So what's 2 squared? 4. 1 over 4. 1 minus 1/4 is 3/4. So it means that 3/4 of your data is going to lie within 2 standard deviations of the mean. Here's your mean, 2 standard deviations this way, and divided 2 standard deviations this way, right? So within 2 standard deviations, 75%, at least 75%, at least. That means 75% to 100% will lie within 2 standard deviations. So Chebyshevs gives you a minimum. It says that much or more will lie within 2 standard deviations. Keep going, Jake.
For k equals 3, at least 8 out of 9 or 89% of all values lie within 3 standard deviations of the mean.
Right? Because when you're talking about 3 standard deviations, then 1 minus 1 over 3 squared. 3 squared is 9. 1 over 1/9, 1 minus 1/9, 8/9. So at least 8/9 of your data will lie within 3 standard deviations of the mean. So if you go 3 standard deviations this way, 3 standard deviations this way, then at least 8/9 of your data will lie within this. Usually more, but at least minimum 8/9, which means Chebyshevs is valuable and important because data doesn't have to be normal. I challenge you to make up numbers. Bring me any set of numbers, and this will be true. You can't even make up an imaginary set of data and break this rule. No matter what you do, if you go 3 standard deviations in either direction, at least 8/9 of the data will fall within 3 standard deviations. And at least 3/4 of the data will fall within 2 standard deviations. That's the really cool thing about Chebyshevs, is it applies to any data set. Doesn't have to be normal. And at least, like I said, at least means at least that much, usually more. So someone before had said, well, does that violate our thing we just learned a second ago about roughly 95% of the data lies within 2 standard deviations? So earlier we talked about the usual values, 95% usually lie within 2 standard deviations. Is 95% at least 75%? Yeah, so it totally falls within that. Does that kind of make sense? All right, so here's a visual, what I'm talking about. Chebyshevs, if I go 2 standard deviations this way and 2 standard deviations that way, then at least 75%, maybe more, will fall between those 2 values. If I go 3 standard deviations this way and 3 this way, then at least 88.89, 8/9 of the data will fall between those 2 values. should do this example. It's at the very bottom of the page. IQ scores. Let me just add up these guys, 'cause these are all So did you guys get the first part? Did you guys fill in the blanks for the first part? So these are the blanks you should have filled in at the bottom of this page.